Neptune is the 8th planet from the Sun and is known for its striking blue color, which comes from the presence of methane in its atmosphere. It's a gas giant, similar to Uranus, and has a very dynamic atmosphere with strong winds and storms. Neptune has 14 known moons, with Triton being the largest and most notable due to its retrograde orbit and geysers. It was discovered in 1846 and is located about 4.5 billion kilometers, 2.8 billion miles from the Sun. But have you ever wondered about the mysteries of Neptune? Hi guys, welcome back to our channel. In today's video, we will see how NASA reveals Neptune is not what we're told about. Dark, cold, and whipped by supersonic winds, ice giant Neptune is more than 30 times as far from the Sun as Earth. Neptune is the only planet in our solar system not visible to the naked eye. In 2011, Neptune completed its first 165-year orbit since its discovery in 1846. Neptune is so far from the Sun that high noon on the big planet would seem like dim twilight to us. The warm light we see here on our home planet is roughly 900 times as bright as the sunlight on Neptune. The ice giant Neptune was the first planet located through mathematical calculations. Using predictions by Urban Leverrier, Johann Galle discovered the planet in 1846. The planet is named after the Roman god of the sea, as suggested by Leverrier. For decades, the data collected from Voyager 2's flyby in 1989 was the cornerstone of our understanding of this distant world. However, recent revelations and updated data from NASA have begun to reshape our understanding of Neptune in ways that could be groundbreaking. Reevaluating Neptune's atmosphere. For years, Neptune's atmosphere was considered relatively simple, a mix of hydrogen, helium, and methane. The latter is responsible for its distinctive blue color. However, recent observations have revealed that the planet's atmospheric dynamics are far more complex than previously thought. NASA's observations from the Hubble Space Telescope and the James Webb Space Telescope have uncovered new details about Neptune's weather patterns and climate. For instance, the existence of a mysterious dark spot on Neptune was confirmed, which is essentially a large storm system. The size and longevity of these dark spots have been subject to new analysis, showing that Neptune's storms can be much more intense and long-lasting than previously believed. Recent advancements in observational technology have prompted the re-evaluation of Neptune's atmospheric characteristics, revealing a much more complex and dynamic system than previously thought. Number 1. Enhanced observational techniques. Recent observations from the Hubble Space Telescope and the James Webb Space Telescope, or JWST, have provided more detailed and high-resolution images of Neptune's atmosphere. These new observations have uncovered a variety of atmospheric phenomena that were not fully understood before. The JWST's infrared capabilities, for example, allow scientists to study the planet's atmosphere in greater detail, revealing new insights into its composition and weather patterns. Number 2. Complex weather systems. Neptune's atmosphere is known for its extreme weather conditions. The planet's strong winds, some reaching speeds of up to 2,100 kilometers per hour, or 1,300 miles per hour, were previously documented but not fully understood. New data have shown that these winds contribute to the formation of large storm systems, including the planet's famous dark spots. These dark spots are massive storm systems that resemble the cyclones found on Earth, but with much more intense dynamics. Recent observations indicate that these storms can persist for longer periods than previously thought and can be more dynamic. The presence of multiple dark spots and their shifting positions suggest that Neptune's weather is highly variable, with complex interactions between atmospheric layers. Number 3. Methane and cloud formation. Methane plays a crucial role in Neptune's atmosphere, absorbing red light and giving the planet its blue color. Recent studies have provided new insights into how methane interacts with other atmospheric components to influence cloud formation. Observations have revealed the presence of high-altitude clouds composed of methane ice, which appear as bright, streaky features in images from the JWST. These clouds are thought to be part of a broader system of atmospheric circulation that involves both planets' fast winds and temperature variations. The detailed spectral data from recent missions have allowed scientists to map the distribution of methane and other trace gases more accurately, leading to a better understanding of how they affect the overall atmospheric composition and cloud dynamics. Number 4. Seasonal changes and long-term variations. Neptune's atmosphere also exhibits seasonal variations. The planet's long orbit around the Sun means that it experiences significant seasonal changes over its 165-year orbital period. Recent observations have detected changes in the atmospheric structure and storm activity that correlate with these seasonal shifts. This includes variations in the intensity and frequency of storm systems, which are linked to changes in the planet's overall energy balance. Orbit and rotation. One day on Neptune takes about 16 hours, the time it takes for Neptune to rotate or spin once. And Neptune makes a complete orbit around the Sun, a year in Neptunian time, in about 165 Earth years, 60,190 Earth days. Sometimes Neptune is even farther from the Sun than dwarf planet Pluto. Pluto's highly eccentric, oval-shaped orbit brings it inside Neptune's orbit for a 20-year period every 248 Earth years. This switch, in which Pluto was closer to the Sun than Neptune, happened most recently from 1979 to 1999. Pluto can never crash into Neptune, though, because for every 3 laps Neptune takes around the Sun, Pluto makes 2. This repeating pattern prevents close approaches of the two bodies. Neptune's axis of rotation is tilted 28 degrees with respect to the plane of its orbit around the Sun, which is similar to the axial tilts of Mars and Earth. This means that Neptune experiences seasons, just like we do on Earth. However, since its year is so long, each of the 4 seasons last for over 40 years. Moons of Neptune. Neptune has 14 known moons, each with its own unique characteristics, but its largest and most intriguing moon is Triton. Triton is extremely cold, with surface temperatures around minus 391 degrees Fahrenheit, minus 235 degrees Celsius, and yet despite this deep freeze at Triton, Voyager 2 discovered geysers spewing icy material upward more than 5 miles or 8 kilometers. Triton's thin atmosphere, also discovered by Voyager, has been detected from Earth several times since and is growing warmer, but scientists do not yet know why. Triton stands out due to its retrograde orbit, meaning it orbits Neptune in the opposite direction to the planet's rotation. This unusual orbit suggests that Triton was likely captured by Neptune's gravity rather than forming in place. Another significant moon is Proteus, the largest of Neptune's inner moons. Proteus is irregularly shaped and heavily cratered, indicating a history of impacts. Nereid, one of Neptune's outer moons, has a highly elliptical orbit, which is unusual for a moon and contributes to its extreme distance variations from Neptune. Other moons, such as Larissa, Despina, and Galatea, are smaller and less well studied. These moons are predominantly composed of rock and ice and orbit Neptune relatively close to the planet. They play a role in shaping Neptune's ring system and contribute to the planet's gravitational interactions. The diverse range of Neptune's moons, from Triton's geysers to the irregular orbits of Nereid and others, provide valuable insights into the dynamics of moon-planet interactions and the history of the Neptunian system. Future missions and observations could reveal even more about these intriguing celestial bodies. Neptune's rings are faint and less well known compared to those of Saturn, but they are still a fascinating feature of the planet. There are 5 main rings around Neptune. Neptune's rings are composed of dark particles, which may be made of a mixture of water, ice, and other substances. The rings are not as prominent as those of Saturn due to their low reflectivity and the fact that they are made up of smaller, darker particles. Surface. Neptune does not have a solid surface. Its atmosphere, made up mostly of hydrogen, helium, and methane, extends to great depths, gradually merging into water and other melted ices over a heavier, solid core with about the same mass as Earth. Atmosphere. Neptune's atmosphere is made up mostly of hydrogen and helium with just a little bit of methane. Neptune's neighbor, Uranus, has a similar makeup. The methane absorbs other colors but reflects blue, giving these ice giants their similar hue. Many images of Neptune coming from the Voyager 2 flyby in 1989 show Neptune as a much deeper blue. This was because the Voyager team tweaked the images to better reveal clouds and other distinctive features on the planet, compared to the hazy, uniform view of Uranus that Voyager 2 had captured back in 1986. Researchers in 2024 reprocessed the images, showing the planets look much more alike than many thought. Neptune is our solar system's windiest world. Despite its great distance and low energy input from the Sun, Neptune's winds can be 3 times stronger than Jupiter's and 9 times stronger than Earth's. These winds whip up clouds of frozen methane across the planet at speeds of more than 1,200 miles per hour, 2,000 kilometers per hour. Even Earth's most powerful winds hit only about 250 miles per hour, or 400 kilometers per hour. In 1989, a large oval-shaped storm in Neptune's southern hemisphere, dubbed the Great Dark Spot, was large enough to contain the entire Earth. That storm has since disappeared, but new ones have appeared on different parts of the planet. Magnetosphere. The main axis of Neptune's magnetic field is tipped over by about 47 degrees compared with the planet's rotation axis. Like Uranus, whose magnetic axis is tilted about 60 degrees from the axis of rotation, Neptune's magnetosphere undergoes wild variations during each rotation because of this misalignment. The magnetic field of Neptune is about 27 times more powerful than that of Earth. Hope this video could add value to your thoughts. Do like, comment, and share. Stay tuned.